Okay, let me start over. With all the news coming out of Tennessee about the devastating wildfires, today's special presentation from Uponor is especially timely. Because if you're planning to install fire sprinklers in the homes you build, upfront decisions about the underground materials and components can save you money down the road when it comes time to construct the home. By using proper fire sprinkler design, the hope is that we can do a lot less rebuilding after a residential fire. To learn more about the important things to know and consider before breaking ground on a fire-sprinkled home, we have Melissa Rodriguez here to help us out. She's the supervisor for fire safety design services at Uponor. She's also a professional engineer who holds more than 12 years in the industry with a NICET Level 4 certification in fire sprinkler design. Melissa received her bachelor's degree in mechanical engineering from the University of Minnesota. She recently got her master's degree and is a professional member of the National Fire Sprinkler Association, the National Fire Protection Association, and the American Fire Sprinkler Association. She is also the vice chair of the Communications Subcommittee for the NFSA Future Leadership Committee, an alternate member of the NFPA Residential Technical Committee, and the Governor's Council Liaison for the Minnesota chapter of the Society of Fire Protection Engineers. If you have any questions during the course of today's presentation, you can submit those for our guest by using that questions box over on the right side of your screen. I'll review those questions and pose them to Melissa during the Q&A time set aside after her presentation. Melissa, we're anxious to hear your advice.
Thanks, Mike. So today I'm going to be talking about all of the pre-planning steps that you need to make when prepping for a building development, a housing development that would be fully sprinklered. That is going to consist of going over the parts of the underground supply, which will include meters and meter setters, the selection of the pipe type and size, backflow prevention, pressure reducing devices, and then information about how to connect with your local water authorities, in addition to plenty of other information. So jumping right in, I'm going to first go over the main water supply components that make up the supply for a typical residential sprinkler system. It's going to include the water main in the street. That's the most typical source of a water supply for a home. It's going to be the supply piping that goes from that main into the house. It includes the water meter. And then on the system riser in the house itself, you've got your basic shut-off ball valve. As long as that ball valve is full port, there won't be any noticeable fixed losses, so I won't go into too much detail about that. After the ball valve, the system riser will then have a T that's going to go off to your water heater, a possible secondary T that's going to go to the cold water fixtures in the home if we're dealing with a standalone sprinkler system. Otherwise, if we are not, and we are dealing with a multi-purpose sprinkler system, you may have some additional lines coming off of your riser to feed any cold water fixtures that you would like to remain independent of that sprinkler system. Otherwise, the remainder of the pipe will supply both the sprinklers and the cold water fixtures throughout the home. These water supply components shown here are all that is required for the most simplistic residential fire sprinkler system, which is a multi-purpose system, where that piping throughout the home is supplying the sprinklers and the water fixtures. I will also go over what's required in many areas when standalone sprinkler systems are selected. Some of the additional components that you may see on your supply line into your residential sprinkler system are shown here. Those include pressure reducing devices, backflow preventing devices, meter setters, and water softeners. Water softeners is also going to include things like water filters of many different types, anything that's going to be incorporated into that supply line into the home that could potentially restrict the available water flow into the home. I want to point out that it's important to note none of these are required to be listed for fire protection. All sprinklers and pipes supplying the sprinklers are required to have certain listings to be used in a fire sprinkler system. However, per NFPA 13D, the water supply components, such as the meters, pressure reducing valve, and etc., are not required to carry any special fire sprinkler listing. It is important to note, though, that if this supply line is feeding your potable water drinking fixtures, that they all need to be completely lead-free. Speaking of the water main, since that's where we get started for any sprinkler system, the size of the water main does have an impact on how we go about designing the sprinkler system. NFPA 13D allows for any water main 4 inches or larger. You can use the static pressure alone to compare the hydraulic demand of the sprinkler system to the available water pressure. For 13R or 13 systems, it is often required that a full hydrant flow test be conducted, where you measure both the static pressure and the residual pressure when flowing a large amount of water, usually out of a nearby fire hydrant. This is used to establish a curve that will tell you how much water pressure you have available at various flows. However, for 13D sprinkler systems, the flow required is often very, very small compared to the larger sprinkler systems seen for 13R or 13 systems. Sometimes as little as 26 or even 20 gallons per minute is all that is required to supply a residential sprinkler system. Therefore, hydrant flow tests may not be required for every sprinkler system installation in residential development. I do want to caution, however, that if the local water authority or the fire department or whomever the authority having jurisdiction will be requires that flow test, it will still need to be conducted and used in the design of the system. It's important to note that pressure readings are dependent on elevation in comparison to the sprinklered home that we are designing. Static pressure will decrease as you move up in elevation, and obviously it will also increase. So it's important to provide any elevation differences between the point where the pressure was read and the elevation of the home itself. If a site plan showing the water utilities for a sprinkler development is available, it can be extremely useful for your design or engineer to be able to determine changes in elevation or even identify the potential for different water pressure zones, which is also something that can happen for larger development. It's not uncommon for a single housing development to have different pressure zones with a pretty distinct dividing line. And it's important for that to be incorporated into the sprinkler design. When we're looking at meter selection, in some cases you may not have as much of a choice as you would like. Often water purveyors have standard meter assemblies that are installed for every new home. These meters shown here are some pretty standard water meters. They look very, very similar. However, one is a 3/4 inch, the other is a 5/8. I also want to point out some of the advances in meter technology. This is showing a census meter that has much higher efficiency, which means that there is less unrecorded water usage, and it has lower fixed losses than some of the older meters. Some may tell you that if you are installing a fire sprinkler system on a home, you must have at least a 1-inch meter, or sometimes you will hear that even a larger meter is required. This is absolutely not true. As I stated, the flows required for a 13D sprinkler system are very low, and a standard 3/4 by 3/4 inch meter is rated to flow a maximum of 30 gallons per minute. And I'm going to talk a little bit more about what that maximum rated flow means on the next slide. But what I want to make sure to point out is a 3/4 inch meter is often more than okay for a residential sprinkler system. It can be important to provide the make and model of the meter to your designer because they can then incorporate the published fixed losses for that meter instead of having to use the tables provided in NFPA 13D, which often have higher fixed losses than what the actual published losses are from the manufacturer. There are going to be some cases where the sprinkler demand will exceed the demand allowed by a 3/4 inch meter. And there are a couple of solutions for cases like that. One is that some meter manufacturers are coming out with meters that allow for larger flows than what has been typical in the past. Badger, for example, makes a record-all meter that is rated to flow 35 gallons per minute. Now, why is it so important to that, why am I putting so much importance on this fact that a 3/4 inch meter should be allowed? Is that some water purveyors will charge very large amounts of money to upsize to a 1-inch meter or larger. This is, like I said, larger meters tend to drop off in efficiency, and water purveyors don't want to lose potential income or have unrecorded water flowing through these larger meters. There are, potential situations where there could be a small leak or a toilet that's running, and it's not flowing enough to register on that meter. If the water purveyor is open to speaking with the development team or the builder, and they can be convinced that the increase in costs should be only in the amount of the component itself, so only how much more a larger water meter costs, that would be ideal, especially in situations where the sprinkler system is required by code. I mentioned maximum rated flows, and the one thing that I want to point out from this slide is the difference between the maximum continuous operation flow that's allowed and the maximum allowed flow for intermittent usage. So continuous operation means 24 hours a day, 7 days a week, that it can flow and there would be no damage to the meter and no loss in metering capabilities. For a 3/4 inch meter, this is about 15 gallons per minute typically. And like I said, though, the typical operating range can go all the way up to 30 gallons per minute. So that is the maximum allowed flow of a standard 3/4 inch meter. And intermittent is absolutely something that would include a sprinkler flow. This is something that's going to be extremely rare, and it's theoretically only going to be happening for what is considered a short amount of time. The required duration of a sprinkler system flow per NFPA 13D is 10 minutes for most homes. This is to allow time for the local fire department to respond to the fire and arrive on scene, at which point they would take over control of the fire and they would close the shutoff valve and stop flow to the sprinkler head, excuse me. It's important to note that 5/8 by 3/4 inch meters still have a 5/8 body with the same flow restrictions as a 5/8 meter. Now, as you can see, I'm pointing this out because a 5/8 meter has a typical operating range of only 1 to 20 gallons per minute. Our typical sprinkler demand of 26 gallons per minute exceeds this 20 gallon per minute range. Now, there has been testing done by the Fire Research Foundation to prove that these 5/8 meters actually are more than capable of flowing beyond this maximum allowed flow. As long as the additional pressure loss, which can be significant, is incorporated into the design, their conclusion was there's no reason that you would not be able to use a 5/8 meter on a typical sprinkler system. Now, this may be true, but there are also going to be some risks involved in continuing with the use of a 5/8 meter on a sprinkler system that requires a flow higher than its maximum rating. One option is to use low-flow sprinkler heads, which can flow as little as 10 gallons per minute, and then our demand of the most remote 2 sprinklers would be a total of 20 gallons per minute, which obviously is within that maximum range. This is definitely a good solution. However, low-flow sprinklers have restrictions on spacing. They cannot be spaced as far apart as the standard residential sprinklers. You are often limited to 14 by 14, where you can have 16 by 16 spacing, or even 18 by 18 when using standard residential sprinklers. The possible risk that's involved in exceeding the flow of a 5/8 meter mostly comes in the extremely unlikely event of a system failure. In the event of a system failure where some tragedy may occur, an investigation will likely take place, and something like the meter being designed outside of its maximum rated flow could be considered a factor in that system failure. So it should be very heavily weighted when considering the risks of moving forward with a design that exceeds the rating of your water meter. And now I want to talk about the various supply piping that would be going between your city main and your meter, and then from the meter to the system riser in the home. It's important to note that all pipes are not created equal. These could all be 1 inch, and they would have different internal diameters. The internal diameter of PVC and copper is often going to be larger than the internal diameter of PEX or various kinds of poly. So where a 1 inch PVC underground supply may be more than okay as far as how much pressure we're losing, the same distance of 1 inch PEX or poly would lose significantly more of your available pressure. This is because as we're flowing water through the pipe, you're losing some of your pressure for every foot that you're traveling down the pipe. The friction caused by the water rubbing against the pipe walls is going to strip away your pressure as you go. So the longer the distance, the more pressure you're going to lose. This pressure loss also increases as your pipe size goes down. One thing to note is even if you have a 3/4 inch meter, when you're talking to your water purveyor, they often call it a 3/4 inch tap. And that notation right there should throw up some red flags, because if they see 3/4 inch tap, that gives me the impression that they're planning on running 3/4 inch from the city main to the meter, and then they'll tell you that from that point on, you can increase and go the rest of the way into the home. However, it's completely acceptable to have a larger tap into the city main and still go with a smaller meter. While you will have to put in additional reducing components if you start with 1 inch off of your city main and go into a 3/4 inch meter, this is going to help significantly in the reduction of that pressure loss. 3/4 inch as a supply line for a residential sprinkler system is often going to lose very significantly high amounts of pressure. You can have very small distances of 3/4 inch, and you may not lose more pressure than would be allowed for the sprinkler system demand. However, as soon as you exceed even 20, 30, 40 feet of 3/4 inch pipe at standard sprinkler system flows, you're going to see some very significant drops in your pressure. So if at all possible, 3/4 inch supply lines should be avoided when you're supplying a residential sprinkler system. Pressure reducing devices are used very commonly in areas where your incoming static water pressure exceeds the rating of your plumbing fixtures. Most of the time that rating is around 80 psi. So anytime your incoming static pressure exceeds 80 psi, you will more than likely have a pressure reducing valve installed in the line going into your home. Now, all pressure reducing valves are not created equal, and it is very important to find and note the pressure loss at the flows that you will see for that residential sprinkler system. 3/4 inch Watt 25 AUB is a very commonly used pressure reducing valve. However, it has a significant pressure drop, much, much higher than similarly sized Apollo pressure reducing valves. However, we would never recommend a 3/4 inch pressure reducing valve. It may be more anecdotal than anything else, but I have not seen many 3/4 inch pressure reducing valves that are capable of flowing what is required for a sprinkler system. And we're able to verify this because we always recommend that your residential sprinkler system be flow tested. And we have not seen that flow test pass anytime smaller than a 1-inch pressure reducing valve has been used. Now, like I state here, Apollo pressure reducing valves have low pressure drops, and if they're available in your area, they are definitely a good option. Now, I'm not advocating for any particular manufacturer of pressure reducing valves, and I'm definitely not trying to point out anything negative about Watts, because Watts also has other models of pressure reducing valves that are going to be much more ideal for fire sprinkler systems. I'm just trying to point out that it's important to pay attention to what is being installed on the system. If there are pressure reducing valves installed that the designer doesn't know about, there's going to be some pretty significant issues of the system design thinking that we have enough pressure, but in reality there's this huge amount of loss through a valve that your designer was not aware of, and this can cause some issues when you're trying to verify your system performance. Backflow prevention devices are something that you will only usually see for standalone sprinkler systems. They are not actually required in the NFPA 13D standard. This is something that is a requirement of your local water authority. And it's not a guarantee that using a multi-purpose sprinkler system will exempt you from their requirement to use backflow prevention. In some areas, backflow prevention is required regardless of whether a sprinkler system is installed or not. And in those cases, then that backflow prevention device would need to be incorporated into the sprinkler system design. Luckily, most of the common backflow prevention devices do not have the high fixed losses like you will see with pressure reducing valves. It is very important, though, to try to talk to that water purveyor. If they're requiring a backflow preventer, you should ask the questions, would this be required if this was not supplying a sprinkler system? If the answer is no, then you move into, well, is this a standalone or multi-purpose? Because if it's a multi-purpose sprinkler system, every component is rated for potable water and is completely lead-free. And if installed correctly, there should be no stagnant water in your multi-purpose sprinkler system. Therefore, a backflow prevention device should not be required. This can be sometimes a difficult conversation because a lot of water purveyors are used to simply requiring them on sprinkler systems no matter what. They don't have any allowances for lead-free or potable systems. Sometimes this can be a matter of education, and sometimes there's just a point where you know whether or not it's a battle that you're going to win. And why is this such an important topic? You would say, well, let's just put it in and be done with it. Obviously, there's additional cost involved in every extra component, but it's important to note which type of backflow prevention device is being used. Some of the different types are going to be your single check, your dual check, or what's known as a reduced pressure zone valve. Sometimes these terms can be used interchangeably. A water purveyor may call out the requirement for an RPZ because that's the language that's used in some of the cross-connection booklets that are provided from various water authorities. However, if you go further into the requirements for backflow prevention, the RPZ is not always going to be required if we're talking about residential sprinkler systems. Often that term is used when a dual check valve or detector check valve should be used instead. Reduced pressure zone valves often have requirements for costly annual maintenance that should be avoided if possible, because we don't want to have additional costs have to be incurred by our future homeowners. Another component that is often overlooked when the initial sprinkler design is being considered is a meter setter, or sometimes it's called a meter yoke. Now, this is a device that's typically used to raise the meter up into a location, making it easier to read and easier to service. Sometimes it's in a meter box that can then be accessed more easily by the meter reader. You can see here an example of that meter yoke and it lifting the meter up into a box in the ground. The issue with these meter yokes is that they often have very high pressure losses, and they're often not incorporated into the initial design. It's not something that people usually think about, or maybe they don't even realize that it's something that's going to be used. If it's known ahead of time, and if it's possible to select larger sizes, it may not be a complete deal breaker for a sprinkler system to have a meter setter installed in the supply line. The issues come in when, like I said, it's not initially designed into the system, or if it's a smaller size. For a 3/4 inch meter, the components of the meter yoke are often as little as 5/8 for the tube that goes up to the connections on either side of the meter. Additionally, the components that can be incorporated into that meter yoke can be varied. There can be check valves or pressure-reducing valves incorporated at those junction points where the meter is sitting. The other difficult aspect of these meter setters is that the variation in the components and the sizes means there are no readily available published fixed losses for meter setters. The manufacturer can provide those losses at various flows, and often a water purveyor that uses these on all of their homes may have a standard assembly, but it is going to be important to obtain the information on that assembly so that it is incorporated into the design. Ideally, an alternative solution to a meter setter would be allowed, instead of one of these devices, which can have such a restrictive impact on your sprinkler system flow. Now I'm going to talk a little bit about water softeners and how they can be incorporated into a sprinkler system without having a very large impact on the performance of your sprinkler system. Typical water softeners will not have a flow rate high enough for sprinkler system demands. And this is also true of filtration devices. They do exist, but as is probably expected, they're going to be more costly than a standard water softener. So when water softeners are present, NFPA 13D requires that some form of bypass be installed so that when a sprinkler operates, the softener is bypassed and water instead flows at a more direct path to the sprinkler. A mechanical means of accomplishing this bypass can be used by incorporating a pressure-reducing valve. If you see here, I'm showing a typical sprinkler riser. We tee off and we go into the water softener. We come back out of the water softener and we tee back into our main sprinkler riser. In between those two tees, you can see a pressure-reducing valve and a pressure gauge. Now, the way that this pressure-reducing valve works as a bypass is that it is set to only allow water through at a pressure that is slightly higher than what the system demand will be at that point in the event of sprinkler operation. The goal is that through day-to-day operation, the water pressure on the system side of the softener and the pressure-reducing valve is higher than the set pressure of the valve. In that case, the water itself acts as a barrier to allowing water to flow through that pressure-reducing valve. Then when a sprinkler operates, the pressure in the system will drop significantly enough that the pressure at that valve will be low enough that water will begin to flow through there. It's important as well to pay attention to the valve being used as your bypass, because the water will be flowing directly through the valve when you have sprinkler operation. Additionally, if this is going to be installed in a scenario where you also have high incoming static water pressure, it can be important where the placements of your pressure-reducing valves are located. You will need 2 pressure-reducing valves in the event of high incoming static water pressure, because you will want to make sure that you don't have high pressure going to your softener or to any non-softened water fixtures that will also not be coming off of your sprinkler loop. The best scenario is to put your secondary pressure-reducing valve in the line going to the water softener instead of before the T that goes to the water softener. This way, the fixed loss through that pressure-reducing valve will not need to be incorporated into your sprinkler system calculations. And in that scenario, you can use a smaller and less expensive pressure-reducing valve that would have a higher fixed loss if we were having to incorporate it into our sprinkler system demand. Now, I've talked quite a bit about water purveyors, and I just want to make sure to stress the importance of establishing a line of communication with your local water purveyor. They're going to be the ones to decide what kind of meter is installed. Again, the tap size, which does not have to match your meter size. They're going to be the ones enforcing any requirements for backflow prevention. And they're going to be the ones to usually allow for larger than normal supply line sizes. They're going to be, in a lot of cases where they are not useful, or I'm sorry, not used to sprinkler systems being installed in single-family homes, they may not have enough information or enough knowledge about how they work to be able to make informed decisions. In cases like that, sometimes all it takes is some education, and there are a lot of resources that can be used, such as National Fire Sprinkler Association, American Fire Sprinkler Association. You can even reach out to our design services team at Uponor, and we are more than happy to help educate your local water purveyor on the requirements and components involved in residential sprinkler systems. Now, getting close to the end, I know we're going to have some questions. I do see a question about meter sizes, and so I will address that after I finish up here. I just want to show one final slide with some information, that a little reminder actually, that you should not forget about the potential for trade-ups that you're eligible for when you're building a fully sprinkler development. Some of these are going to be the option to have narrower streets, higher housing density. You can have larger spacing between your fire hydrants, and you're going to be able to possibly have reduced water main sizing. The thinking is that when you have a fully sprinkler development, it's not as important to worry about access for fire trucks, accessibility of the fire hydrants to the firefighters when they arrive on scene. There's not as much of a concern for exposure to neighboring homes, and the water mains may not need to be sized large enough to handle a fully involved house fire, since the fire would presumably be controlled very early when it is very small by a smaller amount of water that is provided by a residential sprinkler system. So that brings me to the end of the presentation, and I think we can probably start by addressing a question on meter size, if Mike wants to share that with us.
Hi, I certainly can. So Ivan's got a question, it's more of a disagreement, I guess, but on some designs that require 3 heads, the calculation due to the sprinkler head exceeding the listing specifications, having to go do with slope ceilings and that sort of thing. He's saying that the smaller meter isn't going to work due to exceeding the maximum flow of the listed meter. And the 5/8 meter specifically, it may have a listing showing a maximum flow of 30 gallons per minute. So I didn't know if you could address that.
Yeah, no, that's a very good point. One of the things I was trying to make clear is that while a 3/4 inch meter, which has a maximum rated flow of 30 gallons per minute, is going to be acceptable in most scenarios, there will be scenarios where it is not. There are going to be homes where the design is done with sidewall sprinklers, for example, which may have higher flow requirements that could exceed that maximum rated flow of a 3/4 inch meter. I think the question about sloped ceilings, it used to be that sprinkler manufacturers had published, their sprinkler listings showed that slopes exceeding 4 and 12 up to 8 and 12 had to be calculated at a higher flow, or they had recommendations that if you exceeded 8 and 12, their recommendation from the meter manufacturer would be to conduct a calculation with more than the minimum 2 sprinklers required. This is something that's not required in the 13D standard, and it was only recommended by the meter manufacturers, which again is actually not published anymore in most meter manufacturers' installation guidelines. What the guidelines in 13D state is that when your ceiling configurations exceed the listing of your sprinklers, you will need to work with the the authority having jurisdiction and the engineer to come up with an acceptable solution, which in a lot of cases would be to have more sprinklers operating. I think the main school of thought is that with much more steeply sloped ceilings, the sprinklers may not activate as quickly, and you may be dealing with a much larger fire by the time the sprinklers do activate, in which case more sprinklers may need to activate in order to control the fire. In situations like this, where we are exceeding the maximum rated flow of a 3/4 inch meter, I would absolutely recommend going with a 1 inch meter. Standard 1 inch meters have a maximum rated flow of usually 50 gallons per minute, and there are not a lot of scenarios that I have come across with residential sprinkler design that exceed a flow of 50 gallons per minute on the demand of the sprinkler system.
I wanted to make sure to extend the opportunity to everybody. If they do have a question, whether it be highly technical or not, please send it in using the questions box over there on the right side. Ivan certainly did. Robert's got a question as well, specific to rural and well applications. Are you going to need electric backup there?
There's no requirement to have any sort of emergency generator backup when you're dealing with a well or something like that. Obviously, with well systems, if you run out of power, your pump isn't going to work, and that could be a problem in the event of a fire. So while not required, I would recommend having an emergency power backup. If I were, building a home in a rural area where my only water supply was a well or a tank and pump with an electrically operated pump, I would probably want to install that backup. However, it is not required in NFPA 13D. The premise of 13D is that it's the minimum standard for what should be incorporated into a residential sprinkler system. This is to keep costs down as low as possible. But again, being the minimum standard, you can always exceed the minimum standard and install additional safeguards to system failure.
Okay. I had a question. You mentioned that the fire department shuts the system off when they arrive. It's probably nearly the same as the response time, but do you, or whether it be UPNOR or NFPA or any entity, have any data or at least some kind of range on how many minutes a system typically runs when there's a home fire?
I know there are statistics. I don't have those numbers, right off the top of my head. The statistics on average response time for fire service is, I want to say like somewhere between 7 and 9 minutes. If you have a small single-story home, the required duration of your water supply is actually dropped down to 7 minutes. Again, they're trying to keep costs down, and that 10-minute duration fits right in with average response times. That response time is going to be much higher if it's if they're responding to a fire in a more rural location, and it could be much shorter if the fire department is close. And ideally, when a fire department is responding to a house fire in a sprinkler home, they'll be showing up to simply do the cleanup and to take care of any, lingering sparks. Because in the vast majority of situations, a home fire can be contained, if not extinguished, by even a single fire sprinkler.
Well, not just a rural application, but also in situations where you may have a volunteer fire department, where the firefighters aren't right there at the station when the call comes in. They have to come from somewhere else, all meet at the station, and then head out from there. John's got a couple questions. First of all, when is a backup water supply required?
There's no requirement for backup water supply in NFPA 13D. I know that's pretty straightforward. Yeah, it's there. 13D, like I said, being the minimum standard, they're assuming that you're going to be able to supply your sprinkler system on your available water supply. The only requirement is that it is automatic. So if sprinkler operation drops your system pressure and activates your fire pump, or sprinkler operation simply starts flowing water because of your existing water pressure from the city supply.
Okay. I had another question for you, and this may not be a conventional one, but you referenced on one of your slides 20 and 30 and 50 gallons per minute as far as flow rates for systems. What I'm about to mention wouldn't work, obviously, on a house that's just got a couple of rain barrels. But for those homes that have larger rainwater harvesting systems, could the sprinkler system utilize the rainwater as a primary source and then use potable water as a backup, or do sprinkler systems require potable water only?
No, they absolutely would not require potable water only, but usually in the case of standalone. If you have a multi-purpose sprinkler system, you're not going to want to have, your non-potable water in there, obviously. But for a standalone sprinkler system, you can have a pretty wide range of water sources. There are, in 13D, they list a few water supply sources, such as elevated tanks, stored water source with automatically operated pumps. There are even some situations where somebody could conceivably use their swimming pool water to supply their sprinkler system. The main requirement is that the duration of water available to the sprinkler system is at least 10 minutes for, like I guess, for those larger homes. When a home is when a house is less than 2,000 square feet and is only a single story, then that demand drops to 7 minutes. But if your stored water supply has at least 260 gallons, that's going to meet the requirement for most standard residential sprinkler systems.
Right, right. John had a follow-up question too. Again, a rural situation. What about a rural area when the response time is 23 minutes and the water supply lines are less than 100 gallons per minute, meaning 100 gallons per minute water supply, even from the fire department?
Well, 100 gallons per minute, so that's a little bit tricky because I'm not entirely sure if we're talking about still like a municipal water supply system, or are we talking about a well still if we're talking about a rural area?
Right, and I was trying to get some clarification on that, so I'm hoping that John can respond on that, because I was a little bit confused too. I didn't see anything that talked about 100 gallons per minute on your slides, but I could see where on a municipal supply is what he's referring to. Maybe he's referring to, is that the flow rate on, like, when the fire department shows up in their hoses?
A typical, the fire hose will flow. They'll usually flow maybe like 150 gallons per minute is, I think, a pretty standard from a fire truck. When they bring the truck out and they pump it, they're flowing through their hoses. Like I said, a typical sprinkler system demand is going to be around 26 gallons per minute. That's going to be a very large majority of designs, especially, I mean, speaking personally, because standard residential sprinklers will need to flow 13 gallons per minute to have a 16 by 16 spacing. When we calculate the two most demanding sprinklers, that will give us a demand of 26 gallons per minute. So, you know, if sometimes the line between pressure and flow gets a little bit blurred, and somebody says, well, I've got 100 gallons per minute, I should have plenty, but really what they need to be looking at is how much pressure they have available when flowing 26 gallons per minute. The two are definitely related to each other very closely, but simply having one doesn't guarantee that you will have the other.
Okay. And I've asked John to just restate his question for us so we make sure that we address it, because he has supplied additional information saying that he is referring to a municipal supply where the flow rate in the 4-inch fire main is less than 100 gallons per minute.
Okay.
Or near there. So I'm guessing he's going to send us kind of restate that question, unless you've got enough information to go on that you can kind of address what he's trying to get at.
I mean, like, I'm assuming with a municipal supply like that, where it's a 4-inch fire main, but maybe only capable of flowing 100 gallons per minute, without knowing the rest of the information, I can't really say how much pressure that is providing at 100 gallons per minute. You know, I mean, if for somebody to have enough water pressure to simply run their domestic fixtures in their home, you really, you can't drop much lower than 30 psi. I mean, that's starting to get very low because, like I said, as you're going from that city main into the house, you're losing pressure for every foot you travel through your pipe and your system component. So even though they may only be able to get, say, 100 gallons per minute, if they're able to do 100 gallons per minute at 60 or 70 psi, that should be perfectly adequate for standard residential sprinkler systems.
Okay. Okay. Well, last call for questions from the audience. We certainly appreciate the questions that we've gotten so far. And John, like I said, I hope that we addressed your question adequately as well. I know, and we talked about this before we started, Melissa, that are the slides available for download for future reference? That was one of the first questions that we got. So I just wanted to kind of make everybody know, are they available? And then also to let people know that this webinar is going to be put into the Green Building Media Archives later this week. You will get an email about that following this webinar. So certainly you'll be able to access the recording, but specific to the slides, Melissa.
Yes, yeah, I can absolutely provide those for anybody who might request them, and they should request them through Green Builder. I will provide them to Green Builder, and then they will be able to distribute them.
Great. Okay. Seeing no other questions, I'm going to go ahead and wrap it up. Certainly, Melissa, thank you for your time and sharing this information with us. I think a lot of building officials and city officials really get a lot out of this. So, and I saw that we had a lot in attendance. So, very much appreciate that. I want to thank our audience again for asking the questions, for attending today. We do this for you, so appreciate your being here. Like I said before, this webinar is going to be available in the Green Building Media Archives later this week, so check for that, and like I said, you'll get an email reminder. We're going to be back here on December 14th. That's a Wednesday, and it's going to be at 2 p.m. Eastern. We're going to do a 2018 Code Hearing Roundup with Maureen Gutman of the Building Codes Assistance Project. We're going to go over both the hearings and the preliminary results of the online voting, because that's supposed to be released early next week. So we're also going to compare the 2018 model code with the 2012 and the 2015 codes to see what kind of differences there are. They're small as far as efficiency goes, but there are certainly some technical differences that need to be addressed and talked about. So hopefully you'll be back to join us again in 2 weeks. Until next time, take care, everyone. Bye-bye.